String theory is a theoretical framework in physics that attempts to describe the fundamental nature of the universe. Unlike traditional particle physics, which sees particles as point-like dots, string theory proposes that these particles are tiny, vibrating strings of energy. The way these strings vibrate determines the properties of the particles they represent, such as mass, charge, and spin. In classical physics and quantum mechanics, particles like electrons and quarks are treated as zero-dimensional points. In string theory, these particles are replaced by one-dimensional strings that can vibrate in different ways. Each mode of vibration corresponds to a different particle. For example, a string vibrating in one way might represent a photon, a particle of light. A string vibrating differently might represent a quark, a building block of protons and neutrons. For string theory to work mathematically, the universe must have more than the 4 dimensions we observe, 3 of space and 1 of time. Typically, string theory predicts 10 or 11 dimensions. The extra dimensions are compactified, meaning they are curled up so small that we cannot observe them directly. String theory aims to unify the 4 fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, into a single theoretical framework. Think of a guitar string. When you pluck a string on a guitar, it vibrates to produce a musical note. The type of note depends on how tightly the string is stretched, the thickness of the string, how you pluck it. Now imagine that instead of producing sound, the vibrations of a string in string theory determine the type of particle. A specific vibration could create an electron. Another vibration could create a photon. Just like the guitar string can produce different notes based on its vibrations, strings in string theory produce different particles based on their vibrations. Why is string theory important? Quantum gravity. String theory provides a way to incorporate gravity into quantum mechanics, something traditional physics struggles with. Unified framework. It is one of the few theories that attempt to explain all fundamental particles and forces as manifestations of a single underlying principle. Explains the universe's fabric. It suggests that space and time themselves might emerge from more fundamental strings. Challenges and criticism. Unobservable predictions. The energy scales required to directly observe strings or extra dimensions are far beyond our current technology. Too many solutions. String theory has a vast number of possible configurations, making it hard to identify which one describes our universe. Experimental validation. So far, no direct experimental evidence supports string theory.